A repeater is a device that operates on layer 1 of the OSI reference model. Typically, the repeater receives the digital signal, decodes the bit stream, and with the bit stream encode a new digital signal that is forwarded, that is transmitted over all the other ports of the repeater, in the case of, for instance, a hub. The repeater permit that permit the topology extension, that is, length restrictions can be overcome, and in that way we cover longer distances. The task of the repeater is to adapt the signal to different conditions within the media, and particularly the repeater doesn't perform any error detection or nor error correction. And when the repeater segment the network, the available bandwidth remain the same to each segment connected or interconnected by the repeater, because the repeater doesn't perform any kind of traffic separation. And then we need to remember that the repeater receives the signal, the digital signal, decode the signal, and with the bit stream decoded, encode a new signal that is transmitted over the other port. One of the possible adaptation is the adaptation of different medias. The repeater could receive a digital signal over, for instance, a coaxial cable, and could transmit the signal over an UTP or over a fiber cable. In all the cases, the repeater must share a channel, typically a shared medium, or could connect to another media, for instance, an UTP or fiber that connected the repeater to a hub. And but what is important to remember is that only one device in the entire network can send a packet at a time. In the case of hubs, when we talk about the hub is typically a repeater of several ports, and the hub as the repeater work at the layer 1 of the OSI reference model. In fact, the hub constitutes a concentrator of point-to-point links with different stations or other hubs, and the hub transform the star topology into a logical bus topology. That is, the hub receives the digital signal, decode the digital signal, and re-encode another digital signal, and transmit that new digital signal over the other ports of the hub. It is well, the hubs could be connected. Multiple hubs could be connected in a cascade topology, forming what we call a tree, typically a tree. Then that's why we talk about star tree topology, and this permits that we increase the number of possible stations interconnected with those hubs. Finally, the hubs and the repeaters interconnect different segments and different stations, but all those stations interconnected form what we call a collision domain. That is, any station connected to any segment connected to any repeater or hub could collide with each other. And then, in order to reach higher bandwidth, higher aggregate bandwidth between several stations, we could use a switching function. In fact, in order to implement that kind of technology, we need a hub that is a hub and spoke configuration, but the hub in this case, instead of perform a repeating function, the hub perform a switching function. Then, in this case, we really say that the switch, the internet working device, work at the OSI layer 2. In fact, the big difference we'll see that is that the switch or the switching function is based in the use of a store and forward function. This function will permit to avoid collisions, to adapt different speeds, and to reach higher aggregated bandwidth in the network. That in this case, the switch is used in order to separate the segments, the point-to-point segments, and then we need to understand that in this case we don't use a shared segment, and each point-to-point segment is a dedicated connection between each station and the switching hub or the switch or the LAN switch. And then, in the case of the use of switching hubs or a LAN switch, in fact, this device, this LAN switch, could perform, in fact, two different functions. One is called cut-through, and the other is called store and forward. But in fact, the function performed by that kind of devices is the store and forward. The cut-through, we will see that it's only possible when the speed of the ports have the same bit rate. Then cut-through switches examine only the first byte of the frame to learn the source and destination addresses, and then based in that information, the switch forward the frame over the destination port, but in fact the delay is only about 64 bytes, in order to avoid collisions. But then the switching hubs or the LAN switches that perform this kind of functions avoid collisions because the delay is about 64 bytes. That is 512 bits. But the rates must be exactly the same between the ports involved, between the sender and the receiver. But what is more interesting is the use of this function, that is the store and forward function performed by the LAN switches. In this case, then, the store and forward examine the entire frame. Then the switch typically receive the digital signal, decode the digital signal, but receive the whole, the full frame, examine the frame, and based in the destination address, the destination MAC address of the frame, the switch forward the frame over the destination port. Then, using this kind of function, we will permit the use of different speeds, different ports. For instance, this could be a segment of working at 100 megabit per second, and this could be a segment that works at, for instance, 10 gigabit per second. And this is possible because the LAN switch in that case perform a function called store and forward. After those two important functions, that is cut through and store and forward, the switches perform other functions like learning in order to know which MAC is attached to each port of the switch, and that permits that the switch could filter the forwarding and then forward only the frames only to the ports where the destination address of the frame is located. But for instance, when a frame is sent to a MAC address that is not already known by the switch, in fact, in that case, we will call that an unknown frame, that is a frame destinated to a MAC address that is not already located in one port, one specific port. Then, in that case, unknown frames and broadcast frames are forwarded on all the other ports except the source port, and that kind of forwarding is called flooding. Then, typically, the switches flood the network when the switches receive unknown and broadcast frames. Then we were talking about switching or LAN switches. That is, LAN switches are those devices that perform switching functions or bridging functions. In fact, we call that kind of forwarding technique transparent bridging. That is, the end systems exchange frames, and they are not aware of this device. They don't need to configure any kind of parameter in each end system in order to use this device. This is transparent like a repeating hub. But the difference between a LAN switch and the repeating hub is that the LAN switch perform typically a store and forward function. The store and forward function, in fact, is the end system. This station, for instance, transmit a digital signal over this point-to-point segment. This could be a twisted pair or a fiber cable, typically with the possibility to transmit over a twisted pair or over a fiber, and to receive over another twisted pair or another fiber. And then when this end system transmits the digital signal frame over this segment, this device, this LAN switch, will receive the digital signal and receive and store the full frame, the full MAC frame, and after that the switch examine the destination address of the frame and then forward the frame over the other ports. The case, for instance, of a broadcast frame, that is a frame designated to the broadcast MAC address, the switch will perform what we call flooding. That is, the switch will forward that frame over all the other ports, but not over the same port. And in order to avoid, for instance, the misuse of the segments, the switch will perform a filtering functions based in the use of the destination MAC addresses. But in order to perform that function, the switch could perform another function called learning. Using this process called MAC address port learning, the switch could configure dynamically an internal table, and in that internal table, the switch know which MAC addresses are connected to each port of the switch. The learning process is based in the examination of the source addresses of the frames received by the LAN switch. Then finally, when we have broadcast and unknown frames, recall is the frame that the switch received, but is destined to a MAC address that is not already known. That is an address that is not tied to any particular port of the LAN switch. Then, in the case of broadcast frames and unknown frames, flooding is performed, and that's why if we use a redundant topology, loops will happen. And in order to avoid the loops, we do to use what we call a spanning tree protocol as STP. Finally, remember that when we use the store and forward function, this is the function that permits the separation of the collision domain. If this is a switching or bridging entity, this end system will not collide with this other end system. And using this kind of function, we could adapt different bit rates. That is, for instance, this end system could transmit a frame over this segment at, for instance, 100 megabit per second. This switch receive entirely the frame, store it, and then forward it over the other port. It could be a port of, for instance, 1 gigabit per second or 10 gigabit per second. But then the adaptation of the different bit rates is possible because the switch performs this function, that is the store and forward function.